Hi, mathematicians. We are going to summarize writing equations and graphing lines, focusing on slope-intercept form.
So a coordinate graph is made up of a two coordinate axes. Axes is the plural. The x-axis is your horizontal axis and your y-axis is your vertical axis. A coordinate pair, or sometimes called an ordered pair, is a point on the graph that's written in the form, the ordered form, x comma y. To graph that point, or any point, you're going to start at 0, 0, and you're going to move on the x-axis first. That's left or right. If it's negative, you're going to the left. If it's positive, you're going toward the right. And then from that point, you go up or down the amount of y. So negative y is down, positive y is up. So looking at this point right here, point A is negative 4, 3. The x-coordinate is negative 4. The y-coordinate is 3. And if you look here, if you go from 0 and you go left 4 for that negative 4 and up 3 for the positive 3 in the y, you see the point hits right here. So to write the coordinates of the remaining points right here, B, C, D, and E.
Looking for B, you can find that right here. That's at the center. That's at the intersection of the x and y axes. And that's our origin. That's at 0, 0. To look at C, you can see that if we start at 0, 0, that's where we're supposed to start. We would first go left 2, so that would be negative 2. And then we would go down 3, and so that would also be negative. That would be negative 3 for the y value. And this is in a quadrant. The origin is not in a quadrant because it's on both axes. This is our third quadrant. You can label that with the Roman numeral 3 or just the number 3. Recall that we start labeling our quadrants in the positive quadrant. That's the first quadrant, so that's right here. So you can use either way of noting that. Typically, you see it as a Roman numeral. And then you go counterclockwise. So the second quadrant, third quadrant, fourth quadrant. To find point D is just to the right 3. It's not going up or down at all. So its x value is 3 and its y value is 0 because it doesn't leave the x-axis. This also tells me that it is not in a quadrant, it is only on an axis. And then for the last point here, point E is here, it's just straight up 3. So it doesn't go right or left 3, which means that the x-coordinate is 0 and the y-coordinate is 3 because it just goes straight up 3 right here. And again, E is also not on a quadrant because it is on an axis. Remember that slope is the steepness of a line, and slope is also called rate of change. So this is what we've been talking about all year. It has a new name when we're talking about it on a graph, but you can really use those words interchangeably. The slope is the variable m, and it is written as a fraction, and that fraction can be the change in y over the change in x, or you can see that as rise over run. And remember, when you're given slope as an integer, which we sometimes see it that way in an equation, that an integer, just a non-fractional number, and you can make that number a fraction by writing it over 1. 4 over 1, or 4 divided by 1, is the same thing as 4. Negative 5 would be the same thing as negative 5 over 1. Remember that negative can go either in the numerator or denominator, depending on which way you're wanting to plot that, if you're wanting to go up or down first. To find slope on a graph, I look at the line and I'm finding grid points. Now we have dots here that we can use, but if there wasn't an explicit dot there, like right here, there's no dot, but I could still use that to find the slope because that is hitting on the grid of my graph paper at an intersection. I like to make my what I call slope triangle to show my rise over run. So like for this one, I'm going up 3 and then to the right 2. Those are both positive directions. So the slope of this line would be 3/2. To get from this point, I would be going down first if I pick that as my starting point, and that's 1, 2, 3, 4, 5, 6. So that's -6, and then to the right 2. So my slope for this line would be -6/2. And again, some students don't put the positive and negative when they make their slope triangle. They simply count the boxes and then they follow the line and they say, okay, this line is falling, so then they add that negative at the end. Now, if I had, I can reduce this fraction, and if I had gone and noticed that this is a grid point here, I could have gone down 3 and to the right 1, and my fraction would have already been reduced. You can reduce it in making your slope triangle, or you can reduce it afterwards. -6 divided by 2 and 2 divided by 2 also reduces our fraction or slope to -3/1. And finally, looking at this one, I can go up 2, to the right 4. Those are both positive directions. Again, this one has, I could have gone to this middle point, even though there's no dot there. It is hitting at a grid mark, so I could have gone up 1, to the right 2, and my slope is 1/2, or I could reduce 2/4 for that. So positive slopes are increasing as you go left to right. Your finger, if you're tracing it, would be going up. Negative slopes are falling. If you start on the leftmost part of the graph and follow it, if you're going down, it's negative. A zero slope is a special case, and that is for horizontal lines. Undefined slopes are vertical lines. In lesson 4, we talked about slope-intercept form of a line, and y equals mx plus b is that special form for an equation of a line. M represents the slope, and b represents the y-intercept. We've previously talked about slope being rise over run, but to define what the y-intercept the y-intercept is the point where the graph crosses the y-axis. So here is our y-axis, right here, our vertical axis. It is always a good idea to label both your y-axis and your x-axis. And I want you to remember that a y-intercept, because it's on the y-axis, the x value is always 0. That y part we label with the b. So this is what the coordinate would be for the y-intercept. The steps to write an equation of a line is to first find the y-intercept. This is the b value. So we can circle that right here. Here's the y-intercept on my graph. Then to find the slope, and if needed to simplify it, and you want to double check that you are looking if it's positive or negative slope. So for this graph right here, you can see that we are falling. As I go from left to right, it's going down. So I know that my slope is going to be negative. I can put that in my equation right away to make sure that I don't forget to do that. If I'm looking at my rise, I got to see where am I hitting on a grid mark. So I have the dot that is here and the dot that's here. I'm going to use those. I'm going down 3 and to the right 5. So that's positive direction. So my slope here is -3/5. I've already put my negative in my equation, so I just need to finish that off with -3/5. That fraction does not reduce. And I am going to put in my y-intercept, which was at +1. So it's +1 for my equation. To graph an equation of a line, in the equation, we start by circling the slope. Remember, the slope is the coefficient of x. And what I mean by that is that's the number in front of x. So slope is always attached to the x value, even if it's written in a different order. And then it says to underline the y-intercept. This right here is our y-intercept. Our third step here says plot or graph the y-intercept on the y-axis. So in this case, we know that we have -4. So here's our y-axis again. Always label those. And step 4 tells us to plot another point using the slope from the y-intercept. So I am going to do my rise of 5 and my run of 3. And that puts me right here. I went up 5 and to the right 3. Then draw a line between those 2 points. Use a straight edge. That's a ruler, an index card, a folded piece of paper, something to give you a nice straight edge. And then check for positive or negative slope to make sure that your graph is going the way it looks like. So I have a positive slope, so my graph should be increasing from left to right, and it will be. We have a couple of special cases that come from lesson 5, and those are our horizontal and vertical lines. And from the previous slide, you saw that we have the slope is 0 of a horizontal line. And you can see in my example here, this is the example of a horizontal line. And the y-intercept is, we're going to use it in the same way we would for a regular slanted line. It's going to be the point 0b. And our equation, so everywhere along this line, the y value is 2. So like this point right here is 1, 2. This point right here is 3, 2. This point over here is 5, 2. 2 remains the same. So our equation is y equals that b value. So in this specific example, our equation is y equals 2. For a vertical line, you can see that example right here. It's a line that's parallel to the y-axis. It's going up and down. The slope of a vertical line is undefined. Just going to abbreviate that right there. And it doesn't have a y-intercept. You can see this example right here. It does not cross the y-axis. It crosses the x-axis here at 4. And if you look at like this point up here, this point right here would be 4, 3. This point below it would be 4, 2. This point right here is 4, 1. This point way down here is 4, negative 3. You can see that the x value remains 4 everywhere along this line. And this example has a special case equation of x equals 4. So an equation for a vertical line is always x equals where it crosses the x-axis.